Hello and welcome to another episode from Spiral Physics Education. So what we're going to be doing this time is just looking at a couple of exam style questions using Ohm's law. And really what you need to know to be able to get through this is know what current is and how current behaves in series and parallel circuits, know what voltage is and how voltage behaves in series and parallel circuits, and also have an idea about what Ohm's law is. And if you're unsure about any of those, check out some of the videos on the channel to help you to get up to speed on those. Okay, so let's start with a very typical exam question involving current, resistance, potential difference, and Ohm's law in general. So it usually starts off with having some sort of circuit, and here we've got a bit of a description of what's happening to that. And just telling us that we've got a voltmeter across an unknown resistor and it reads 4 volts. And what we're going to be doing is we're asked to calculate the power supplied by the current supplied by the power supply. So the problem with this is that students would do the following. They would realize that it's an Ohm's law question, and they would write V equals IR down, obviously rearranging it, but then they're thinking, well, V is either 4 or 6. I don't know any of the resistors, so you'd have some students using 6 volts and 10 ohms, and you'd have some students using 4 volts and 10 ohms. Both of those would be incorrect, because 6 volts isn't correct because there are 2 resistors with a potential difference of 6 volts across them. And you can't use 4 volts and 10 ohms because the potential difference across the unknown resistor R is 4 volts. We don't know the potential difference yet across the 10 ohm resistor. So the thing here is you've got to think about voltage rules for series and parallel circuits. So if we were to imagine a voltmeter across here, I'm not sure what's happened on there but if we think about an imaginary voltmeter across the 10 ohm resistor, think about what that value is. So we want to use the 10 ohm resistors because we know the value of the 10 ohm resistor, but we don't know the potential difference across that 10 ohm resistor. Can we work it out? Well, try to remember that 6 volts is split across those 2 resistors. So 4 volts plus that unknown voltage is equal to 6. So the potential difference across the 10 ohm resistor is actually 2 volts. So we do know the potential there. So really what you've got to think about is I've got to apply Ohm's law for the 10 ohm resistor. So what's the potential across the 10 ohm resistor? What's the resistance of the 10 ohm resistor? That will tell you the current flowing through the 10 ohm resistor. So the current flowing through the 10 ohm resistor is 0.2 of an amp. That's not quite answering the question yet. So the question says calculate the current supplied by the power supply. You've just worked out the current that's flowing through the 10 ohm resistor. But if you think back to what you understand about series circuits, because this is a series circuit and you've calculated 0.2 amps flowing through the 10 ohm resistor, then that 0.2 amps is flowing through the unknown resistor R and from the power supply. So the actual answer is 0.2 amps is flowing from the power supply. Okay, so in this question we have a slightly different circuit. It's going to be a parallel circuit, and we've got an unknown resistor in parallel with a 15 ohm resistor, and we've also got a power supply of 3 volts, and the students placed an ammeter coming out of the power supply of 0.6 amps. And what we're going to do is we're going to calculate the values of I1 and I2, the unknown currents flowing through in that circuit diagram. And we're also going to then calculate the value of the unknown resistor R. So quite a lot to do. So the first thing to do is to think about the voltage rules for parallel circuits. And if we do that, then we can see that both of the potential differences across the resistor R and the 15 ohms is going to be whatever is the voltage or the EMF of the cell is. So the potential difference across both of these resistors is going to be 3 volts. So the first thing that we can do then is we can apply Ohm's law to the 15 ohm resistor. So we want to find out, we're going to be calculating I2. So we're just applying this to the 15 ohm resistor. So the potential difference across the 15 ohm resistor is 3 volts. The resistance of the 15 ohm resistor is 15, so 3 divided by 15, and that's telling us that the current flowing through the 15 ohm resistor, i.e. I2, is 0.2 amps. So the next thing that we can think about is, well, what about how current behaves in parallel circuits? Well, the way that current behaves in parallel circuits means that actually we can work out that I1 is 0.4 amps. And that's because whatever flows into the junction is flowing out. So the ammeter is saying that 0.6 amps is flowing into that junction. And if 0.2 amps flows through to the 15 ohm resistor, then whatever's left over flows through to our unknown resistor R. Or if you like mathematically, the 0.6 amps flowing into the junction is equal to I1 plus 0.2, and then we can rearrange that to get 0.4 amps. So now we have, so now that we know what the two unknown current values are, we can concentrate on trying to calculate our unknown resistor value R. So just to remind you, think about the voltage rules for the parallel circuits, because it's all about R. We can ignore the 15 ohm resistor now. We don't need to worry about that. So the parallel circuit rules for voltage or potential difference means that the potential difference across R is 3 volts. So that means we can apply Ohm's law for our unknown resistor R. So write the equation down, and we write the potential difference across that resistor, and we divide that by the current flowing through that resistor, and that will tell us the value of that resistor. So I hope you found that little walkthrough of GCSE exam question linking all of those concepts of electricity that we've gone through useful. Don't forget to subscribe to the channel so that hopefully it will improve your understanding of physics and get those grades boosted. And I will see you next time on another episode from Spiral Physics Education. Take care. Bye-bye.